We're going to be dealing with parallelograms, but we talk about parallelograms. Let me say it. Okay, parallelograms. What's the important thing of parallelograms? The opposite sides are parallel. Okay, we learned that before. Like I would do a top side, a bottom side. They were parallel. I will indicate they're parallel by doing arrows. Remember, we used to do that. And then the other two sides happen to be parallel as well. That the only cool thing about parallelograms? Well, not necessarily. Opposite sides are not only parallel, they're also congruent. Remember, we talked about congruent before. Same shape, same size. Okay, they look the same shape, right? Segments, they look the same shape. So same size. Oh, interesting. So opposite sides are not only parallel, but they have the same length. So looking at question 17 and 18, one side is 22. Another side is a -1 plus 23x. And then my instructions are solve for x. I know those sides are equal. Opposite sides are not only parallel, but they are also equal. So let me just write -1 plus 23x equals 22. I'm going to let each of the sides equal each other, all right? I'm going to let those two sides equal each other because I know in the parallelogram, not only opposite sides are not only parallel, but they are also congruent. Right? The rest looks like a simple algebra question. Let me change this to red so we can see the work. I remembered when I have an equal sign, I separate the sides through the equal sign. If I have uh, like terms, I can combine them. If not, I'm trying to have the x by itself. So this -1, I'm going to cancel it. I don't want the -1. I'm going to move it to the other side as a +1. I got to switch signs. So that gives me that 23x, it's equal to 23, right? 22 plus 1, that's how I got the 23. To get the x by itself, let me divide both sides by the number in front of x. Because 23 divided by 23 is 1. But in division or multiplication, 1 is useless. So I'm going to ignore it. So 1x, it's equal to 23 divided by 23 is 1. So x is equal to 1. My instructions were solve for x equals 1. When you answer, you don't have to type in x equals 1. Just the number, just 1. All right, let's take a look at number 18. I see one side is 20. I see this other side right here is 5x minus 5. I know those are the sides that are parallel, but not only they're parallel, but they're also equal to each other. So I'm just going to go 5x minus 5 is equal to 20. And then we'll just solve for x. So let me separate my sides to the equal sign to get the 5x by itself. This minus 5, let me move it to the other side as a plus 5. Don't forget to switch the sign. So that gives me 5x is equal to 25. Now to get the x by itself, let me divide both sides by 5. 5 divided by 5 is 1x. 25 divided by 5 is 5. So x is equal to 5. Let's take a look at question number 19 and 20. Okay, now we're looking at angles. Every time I'm dealing with the sides, I want you guys to see something between these 4 questions. Every time I'm dealing with the sides, the information, the numbers were outside of the parallelogram. Every time we're dealing with angles, the information, the numbers are inside the parallelogram. Okay, so for number 19, the numbers are inside of the parallelogram. So in this case, I'm dealing with the angles. I'm dealing with this angle and this angle. Okay, just like we did with sides, opposite sides were congruent. Same thing with angles. Opposite angles are congruent. So I'm just going to let them equal each other. So I'm going to say 60 is equal to 61x minus 1. Opposite angles are also congruent. Now let me just work this as an algebra question. So let me separate them through the sides. I want the 61x by itself. So this minus 1. I want to move it over as a plus 1. All right, don't forget to switch the signs. So I have the 61 is equal to 61x. Divide by the number in front of x. So in this case, let me divide both sides by 61. So 61 divided by 61 is 1. 61x divided by 61. I know 61 divided by 61 is 1. So 1x. I'm just going to write it as x. X is equal to 1. Now, here number 21, these two angles are not opposite from each other. Right? Opposite will be angle L with angle N. But here I have angle M with angle N. Now, these two are not quite opposite. This is what we call adjacent angles. And we talked about this before. Adjacent angles, angle M and N, adjacent angles, they're not opposite, they're adjacent. They're connected by a side. In this case, what I'm going to do, I'm just going to add both of them up. So I'm going to go 13x plus 1 plus 75. I'm going to add everything up, and this is going to equal to 180. So they're not necessarily equal to each other. They are what we call supplementary. That means you add them up and it equals to 180. All right, the rest is just algebra. Let me separate my sides to the equal side. On the left side, I can probably combine some like terms. When it comes to letters, I just have 13x. When it comes to numbers that don't have a letter, I see a positive 1 plus 75. So 1 plus 75, I usually call that 76. And I'm going to say all of this is equal to 180. Notice I just combined my like terms. Okay, I want 13x by itself. So this plus 76, I'm going to move this over as a minus 76. In reality, I'm really just combining like terms. If I had x's on both sides, I'll move them to one side. So I'll move one of them to the other side. I'm really just trying to combine like terms. Whenever you move something from one side to the other, don't forget to switch the sign. So notice how it was plus 76 and we went minus 76. Don't forget to switch the sign. All right, so I have 13x equals 180 minus 76 is 104. Now let me divide both sides by 13. I always divide by the number in front of x, because here 13 divided by 13 is 1x. 104, so 104 divided by 13 is 8. So sometimes you might be dealing with the sides, sometimes you might be dealing with the angle.